Hello and welcome to another video. A particle moves in a straight line with constant acceleration. Using the equations, we have v equals to u plus at. That's one of the equations of motion. Okay, and s equals to ut plus 1/2 of at squared. Another equation of motion. Now, the first question is for us to eliminate acceleration, that's A, from these equations to show that s, which is distance travel, equals 1/2 of the sum of initial and final velocity multiplied by time taken. Then B, now we want to obtain the equations v squared equals to u squared plus 2as and s equals to vt minus 1/2 of at squared. So now for the first question, we are asked to eliminate a acceleration from these equations. Okay, so what I will do is, so for the first question, now to eliminate a, that's acceleration, from the equations, from the given equations, we have v equals to u plus at and s equals to ut plus 1/2 of at squared. All right, now I want to get rid of a from these two equations such that I will be able to have an equation, for s, which will be equals to 1/2 of the product of the sum of initial and final velocity and time. All right, now, so from this equation, from v equals to u plus at, I'm going to make a the subject of the formula. So let me express a in terms of v, u, and t. That is to make a the subject of the formula. So that this will be v minus u equals to at. And from here, dividing both sides by a, this would by t, we're going to have a to be equals to v minus u over time t. So this equation of acceleration, I'm going to substitute it into the second equation because now we are asked to eliminate a from these equations to show that s, distance travel, equals 1/2 of u plus v multiplied by t. So now, what I'll do now is to substitute v minus u over t for a in the second, minus v over, that's for a, into the second equation. Now the second equation is s equals to ut plus 1/2 of at squared. So that this will be ut plus 1/2 of, now the acceleration is v minus u, change in velocity over time, multiplied by t squared. Okay, so that this will be s equals to ut plus, this will be t squared divided by t, that will be 1t. So this will be 1/2 of v minus u times t. Okay, v minus u times t. Okay, so now this will be ut plus 1/2 of vt minus 1/2 of ut, because v times t, that will be vt. So 1/2 times vt, that will be 1/2 of vt. Then negative u times t, that will be negative ut, multiplied by 1/2, that will be minus 1/2 of ut. So in this case, this will be ut minus 1/2 of ut plus 1/2 of vt. So 1 ut minus 1/2 of ut, that will be equals to 1/2 of ut. So which means this will be, we have 1/2 of ut plus 1/2 of vt. So 1/2 is common, then t is also common. So the equation will be 1/2 of u plus v times t. So this is the required equation after we eliminated a from these two equations. All right, now the second question is for us to obtain the equations v squared equals to u squared plus 2as and s equals to vt minus 1/2 of at squared. So to obtain this equation, to obtain the equation, v squared equals to u squared plus 2as. So from, I will say from v equals to u plus at. So now I'm going to make t the subject of the formula. Now in this case, we are not getting rid of acceleration, okay? We are only asked to use these two equations to obtain these equations. V squared equals to u squared plus 2as, which is the fourth equation of motion, okay? All right, so from here, I'm going to express t in terms of u, v, and a. In terms of u, v, and a. So that means that we're going to have v minus u equals to at. So if we divide this equation by a, this will be v minus u over a equals to at divided by a. So that the equation for time t will be t equals to v minus u over a. That is acceleration, constant acceleration. So I'm going to put this equation into the second equation now. Putting the expression for t into the equation s equals to ut plus 1/2 of at squared. So this will be s equals to, so this is going to be ut, we have ut plus 1/2 of at squared. So this will be u multiplied by v minus u over, over a plus 1/2 of a multiplied by v minus u over a raised to the power of 2. Okay, so now in this case, we're going to have s to be equals to uv minus u squared divided by a plus, so if you square this, this is going to be, now we have a multiplied by, this will be 1/2 of, this is 1/2 of a, then v minus u squared over a squared. So this a will cancel one of this, so we have 1a in this case. So this will be s equals to uv minus u squared divided by a. Then plus, this will be v squared minus 2uv plus u squared over 2a. So now the LCM of this will be, 2a. So if the LCM is 2a, so we have s equals to 2a divided by a, that will be 2. So 2 times uv, that will be 2uv. 2 multiplied by negative u squared. This will be 2 negative 2u squared. Okay, then plus v squared minus 2uv plus u squared. Let me write this again. So this will be s equals to, the LCM is 2a. So this will be 2uv minus 2u squared, then plus v squared minus 2uv plus u squared. Okay, so now 2uv minus 2uv, that will be 0. Okay, then so we have negative 2u squared plus u squared, that will be negative u squared, so that s will be equals to v squared minus u squared divided by 2. So from here, we're going to have 2as to be equals to v squared minus u squared, so that v squared will be equals to u squared plus 2as. So this is, so one of the equations we want to obtain, which is v squared equals to u squared plus 2as, is what we have now, is what we have there. All right, so now to obtain this last equation, okay, now, so still on question B, okay, to obtain s equals to vt minus 1/2 of at squared, okay. Remember, we are using these two equations, okay, to prove, as in to obtain this equation and this equation. So now I'll say from v equals to u plus at. Now in this case, I'm going to make you the subject of the formula. Now I'm going to express u in terms of v, a, and t, so that u will be equals to v minus at. Then I'm going to substitute this, okay, I'm going to substitute v minus at for u in this equation. Now substitute v minus at for u in that's for u in the equation s equals to ut plus 1/2 of at squared. So that will be, so for that equation we have s equals to, now u is v minus at, then multiply by t plus 1/2 of a times t squared. Now multiplying this, we're going to have s equals to vt minus at squared, then plus 1/2 of at squared. Now this is minus 1/at squared plus 1/2 of at squared, so that s will be equals to vt minus 1/2 of at squared. So this is how to obtain the two equations, and this is how to eliminate acceleration A from the two given equation. With that, we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye-bye.